Python is a high-level, general-purpose programming language. Its design philosophy emphasizes code readability with the use of significant indentation. Python is dynamically typed and garbage collected. It supports multiple programming paradigms, including structured, object-oriented and functional programming. It is often described as a batteries-included language due to its comprehensive standard library. Guido van Rossum began working on Python in the late 1980s as a successor to the ABC programming language and first released it in 1991 as Python 0.9.0. Python 2.0 was released in 2000 and introduced new features such as list comprehensions, cycle detecting garbage collection, reference counting, and Unicode support. Python 3.0, released in 2008, was a major revision that is not completely backward compatible with earlier versions. Python 2 was discontinued with version February 7, 18 in 2020. Python consistently ranks as one of the most popular programming languages. History. Python was conceived in the late 1980s by Guido van Rossum at Centrum Wiskunde and Informatica in the Netherlands as a successor to the ABC programming language, which was inspired by SETL, capable of exception handling and interfacing with the Amoeba operating system. Its implementation began in December 1989. Van Rossum shouldered sole responsibility for the project, as the lead developer, until July 12, 2018, when he announced his permanent vacation from his responsibilities as Python's benevolent dictator for life, a title the Python community bestowed upon him to reflect his long-term commitment as the project's chief decision-maker. In January 2019, active Python core developers elected a 5-member steering council to lead the project. Python 2.0 was released on October 16, 2000, with many major new features. Python 3.0, released on December 3, 2008, with many of its major features backported to Python 2.6.x and 2.7.x. Releases of Python 3 include the 2to3 utility, which automates the translation of Python 2 code to Python 3. Python 2.7's end of life was initially set for 2015, then postponed to 2020 out of concern that a large body of existing code could not easily be forward ported to Python 3. No further security patches or other improvements will be released for it. Currently only 3.7 and later are supported. In 2021, Python 3.9.2 and 3.8.8 were expedited as all versions of Python had security issues leading to possible remote code execution and web cache poisoning. In 2022, Python 3.10.4 and March 9, 12 were expedited and March 8, 13, and March 7, 13, because of many security issues. When Python March 9, 13 was released in May 2022, it was announced that the 3.9 series will only receive security fixes going forward. On September 7, 2022, 4 new releases were made due to a potential denial of service attack: 3.10.7, March 9, 14, March 8, 14, and March 7, 14. Removals from Python. The deprecated SMTPD module has been removed from Python 3.12. And a number of other old, broken and deprecated functions, classes, and methods have been removed. The deprecated WSTR and WSTR_length members of the C implementation of Unicode objects were removed, to make UTF-8 the default in later Python versions. Historically, Python 3 also made changes from Python 2, e.g. changed the division operator. Design philosophy and features. Python is a multi-paradigm programming language. Object-oriented programming and structured programming are fully supported, and many of their features support functional programming and aspect-oriented programming. Many other paradigms are supported via extensions, including design by contract and logic programming. Python uses dynamic typing and a combination of reference counting and a cycle detecting garbage collector for memory management. It uses dynamic name resolution, which binds method and variable names during program execution. Its design offers some support for functional programming in the Lisp tradition. It has filter map and reduce functions, list comprehensions, dictionaries, sets, and generator expressions. The standard library has two modules that implement functional tools borrowed from Haskell and standard ML. Its core philosophy is summarized in the document The Zen of Python, which includes aphorisms such as: beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. Readability counts. Rather than building all of its functionality into its core, Python was designed to be highly extensible via modules. This compact modularity has made it particularly popular as a means of adding programmable interfaces to existing applications. Van Rossum's vision of a small core language with a large standard library and easily extensible interpreter stemmed from his frustrations with ABC, which espoused the opposite approach. Python strives for a simpler, less cluttered syntax and grammar while giving developers a choice in their coding methodology. In contrast to Perl's "there is more than one way to do it" motto, Python embraces a "there should be one and preferably only one obvious way to do it" philosophy. Alex Martelli, a fellow at the Python Software Foundation and Python book author, wrote, "To describe something as clever is not considered a compliment in the Python culture." Python's developers strive to avoid premature optimization and reject patches to non-critical parts of the CPython reference implementation that would offer marginal increases in speed at the cost of clarity. When speed is important, a Python programmer can move time-critical functions to extension modules written in languages such as C, or use PyPy, a just-in-time compiler. Cython is also available, which translates a Python script into C and makes direct C-level API calls into the Python interpreter. Python's developers aim for it to be fun to use. This is reflected in its name, a tribute to the British comedy group Monty Python, and in occasionally playful approaches to tutorials and reference materials, such as examples that refer to spam and eggs instead of the standard foo, and bar. The programming language's name Python came from the BBC comedy series Monty Python's Flying Circus. Guido van Rossum thought he needed a name that was short, unique, and slightly mysterious, and so he decided to name the programming language Python. A common neologism in the Python community is Pythonic, which has a wide range of meanings related to program style. Pythonic code may use Python idioms well, be natural or show fluency in the language, or conform with Python's minimalist philosophy and emphasis on readability. Code that is difficult to understand or reads like a rough transcription from another programming language is called unpythonic. Python users and admirers, especially those considered knowledgeable or experienced, are often referred to as Pythonistas. Syntax and semantics. Python is meant to be an easily readable language. Its formatting is visually uncluttered and often uses English keywords where other languages use punctuation. Unlike many other languages, it does not use curly brackets to delimit blocks, and semicolons after statements are allowed but rarely used. It has fewer syntactic exceptions and special cases than C or Pascal. Indentation. Python uses with-space indentation, rather than curly brackets or keywords, to delimit blocks. An increase in indentation comes after certain statements. A decrease in indentation signifies the end of the current block. Thus, the program's visual structure accurately represents its semantic structure. This feature is sometimes termed the offside rule. Some other languages use indentation this way, but in most, indentation has no semantic meaning. The recommended indent size is 4 spaces. Statements and control flow. Python statements include The assignment statement, using a single equals sign equals. The if statement, which conditionally executes a block of code, along with else and elif. The for statement, which iterates over an iterable object, capturing each element to a local variable for use by the attached block. The while statement, which executes a block of code as long as its condition is true. The try statement, which allows exceptions raised in its attached code block to be caught and handled by except clauses. It also ensures that clean-up code in a finally block is always run regardless of how the block exits. The raise statement, used to raise a specified exception or re-raise a caught exception. The class statement, which executes a block of code and attaches its local namespace to a class, for use in object-oriented programming. The def statement, which defines a function or method. The with statement, which encloses a code block within a context manager, allowing resource acquisition as initialization-like behavior and replacing a common try/finally idiom. The break statement, which exits a loop. The continue statement, which skips the current iteration and continues with the next. The del statement, which removes a variable deleting the reference from the name to the value, and producing an error if the variable is referred to before it is redefined. The pass statement, serving as a NOP, syntactically needed to create an empty code block. The assert statement, used in debugging to check for conditions that should apply. The yield statement, which returns a value from a generator function, used to implement coroutines. The return statement, used to return a value from a function. The import statement, used to import modules whose functions or variables can be used in the current program. The assignment statement binds a name as a reference to a separate, dynamically allocated object. Variables may subsequently be rebound at any time to any object. In Python, a variable name is a generic reference holder without a fixed data type. However, it always refers to some object with a type. This is called dynamic typing in contrast to statically typed languages, where each variable may contain only a value of a certain type. Python does not support tail call optimization or first-class continuations, and, according to Van Rossum, it never will. However, better support for coroutine-like functionality is provided by extending Python's generators. Before 2.5, generators were lazy iterators. Data was passed unidirectionally out of the generator. From Python 2.5 on, it is possible to pass data back into a generator function, and from version 3.3, it can be passed through multiple stack levels. Expressions. Some Python expressions are similar to those in languages such as C and Java, while some are not. Addition, subtraction, and multiplication are the same, but the behavior of division differs. There are two types of divisions in Python: floor division / and floating point / division. Python also uses the operator for exponentiation. The @infix operator. It is intended to be used by libraries such as NumPy for matrix multiplication. The syntax equals, called the walrus operator, was introduced in Python 3.8. It assigns values to variables as part of a larger expression. In Python, methods. Methods on objects are functions attached to the object's class. The syntax instance.method is, for normal methods and functions, syntactic sugar for class.method. Python methods have an explicit self parameter to access instance data, in contrast to the implicit self in some other object-oriented programming languages. Python also provides methods, often called dunder methods, to allow user-defined classes to modify how they are handled by native operations including length, comparison, in arithmetic operations and type conversion. Typing. Python uses duck typing and has typed objects but untyped variable names. Type constraints are not checked at compile time. Rather, operations on an object may fail, signifying that it is not of a suitable type. Despite being dynamically typed, Python is strongly typed, forbidding operations that are not well defined rather than silently attempting to make sense of them. Python allows programmers to define their own types using classes, most often used for object-oriented programming. New instances of classes are constructed by calling the class or ex class, and the classes are instances of the meta-class type, allowing metaprogramming and reflection. Before version 3.0, Python had two kinds of classes, old style and new style. Current Python versions only support the semantics new style. The long-term plan is to support gradual typing. Python's syntax allows specifying static types, but they are not checked in the default implementation. See Python. An experimental optional static type checker, MYPY, supports compile time type checking. Arithmetic operations. Python has the usual symbols for arithmetic operators, the floor division operator // and the modulo operation %, where the remainder can be negative, e.g. 4% - 3. Programming examples. Hello World program. Program to calculate the factorial of a positive integer. Libraries. Python's large standard library provides tools suited to many tasks and is commonly cited as one of its greatest strengths. For Internet-facing applications, many standard formats and protocols such as MIME and HTTP are supported. It includes modules for creating graphical user interfaces, connecting to relational databases, generating pseudorandom numbers, arithmetic with arbitrary precision decimals, manipulating regular expressions, and unit testing. Some parts of the standard library are covered by specifications. For example, the web server gateway interface implementation USGIREF follows PEP 333, but most are specified by their code, internal documentation, and test suites. However, because most of the standard library is cross-platform Python code, only a few modules need altering or rewriting for variant implementations. As of November 14, 2022, the Python Package Index, the official repository for third-party Python software, contains over 415,000 packages with a wide range of functionality, including development environments. Most Python implementations include a read-eval-print loop, permitting them to function as a command-line interpreter for which users enter statements sequentially and receive results immediately. Python also comes with an integrated development environment called idle, which is more beginner-oriented. Other shells, including idle and IPython, add further abilities such as improved auto-completion, session state retention, and syntax highlighting. As well as standard desktop integrated development environments, there are web browser-based IDEs, including Sage Math, for developing science and math-related programs, Python Anywhere, a browser-based IDE and hosting environment, and Canopy IDE, a commercial IDE emphasizing scientific computing. Implementations. Reference implementation. CPython is the reference implementation of Python. It is written in C, meeting the C89 standard with several select C99 features. It compiles Python programs into an intermediate bytecode which is then executed by its virtual machine. CPython is distributed with a large standard library written in a mixture of C and native Python, and is available for many platforms, including Windows and most modern Unix-like systems, including Mac OS, and unofficial support for e.g. VMS. Platform portability was one of its earliest priorities. Other implementations. PyPy is a fast, compliant interpreter of Python 2.7 and 3.8. Its just-in-time compiler often brings a significant speed improvement over CPython, but some libraries written in C cannot be used with it. Stackless Python is a significant fork of CPython that implements microthreads. It does not use the call stack in the same way, thus allowing massively concurrent programs. PyPy also has a stackless version. MicroPython and CircuitPython are Python 3 variants optimized for microcontrollers, including LEGO Mindstorm's EV3. Pyston is a variant of the Python runtime that uses just-in-time compilation to speed up the execution of Python programs. Cinder is a performance-oriented fork of CPython 3.8 that contains a number of optimizations including bytecode inline caching, eager evaluation of coroutines, a method at a time JIT, and an experimental bytecode compiler. Unsupported implementations. Other just-in-time Python compilers have been developed, but are now unsupported. Google began a project named Unladen Swallow in 2009, with the aim of speeding up the Python interpreter fivefold by using the LLVM, and of improving its multi-threading ability to scale to thousands of cores, while ordinary implementations suffer from the global interpreter lock. Psycho is a discontinued just-in-time specializing compiler that integrates with CPython and transforms bytecode to machine code at runtime. The emitted code is specialized for certain data types and is faster than the standard Python code. Psycho does not support Python 2.7 or later. PYS60 was a Python 2 interpreter for Series 60 mobile phones released by Nokia in 2005. It implemented many of the modules from the standard library and some additional modules for integrating with the Symbian operating system. The Nokia N900 also supports Python with GTK widget libraries, enabling programs to be written and run on the target device. Cross-compilers to other languages. There are several compilers to high-level object languages, with either unrestricted Python, a restricted subset of Python, or a language similar to Python as the source language. Brython, Transcript, and PyJS compile Python to JavaScript. Cython compiles Python 2.7 to C. Nuitka compiles Python into C. Number uses LLVM to compile a subset of Python to machine code. Python compiles a subset of Python 3 to C++. RPython can be compiled to C, and is used to build the PyPy interpreter of Python. The Python 11 liters C++ transpiler compiles a subset of Python 3 to C++. Specialized. MyHDL is a Python-based hardware description language that converts MyHDL code to Verilog or VHDL code. Older projects. Google's Grumpy transpiles Python 2 to Go. IronPython allows running Python 2.7 programs on the .NET Common Language runtime. Jython compiles Python 2.7 to Java bytecode, allowing the use of the Java libraries from a Python program. Pyrex and Shedskin compile to C and C++ respectively. Performance. Performance comparison of various Python implementations on a non-numerical workload was presented at EuroSciPy 13. Python's performance compared to other programming languages is also benchmarked by the Computer Language Benchmarks game. Development. Python's development is conducted largely through the Python Enhancement Proposal process, the primary mechanism for proposing major new features, collecting community input on issues, and documenting Python design decisions. Python coding style is covered in PEP 8. Outstanding PEPs are reviewed and commented on by the Python community and the Steering Council. Enhancement of the language corresponds with the development of the CPython reference implementation. The mailing list Python Dev is the primary forum for the language's development. Specific issues were originally discussed in the Roundup bug tracker hosted by the Foundation. In 2022, all issues and discussions were migrated to GitHub. Development originally took place on a self-hosted source code repository running Mercurial, until Python moved to GitHub in January 2017. Python's public releases come in three types, distinguished by which part of the version number is increment. Backward incompatible versions, where code is expected to break and needs to be manually ported. The first part of the version number is increment. These releases happen infrequently. Version 3.0 was released 8 years after 2.0. According to Guido van Rossum, a version 4.0 is very unlikely to ever happen. Major or feature releases are largely compatible with the previous version but introduce new features. The second part of the version number is increment. Starting with Python 3.9, these releases are expected to happen annually. Each major version is supported by bug fixes for several years after its release. Bug fix releases, which introduce no new features, occur about every 3 months and are made when a sufficient number of bugs have been fixed upstream since the last release. Security vulnerabilities are also patched in these releases. The third and final part of the version number is increment. Many alpha, beta, and release candidates are also released as previews and for testing before final releases. Although there is a rough schedule for each release, they are often delayed if the code is not ready. Python's development team monitors the state of the code by running the large unit test suite during development. The major academic conference on Python is PyCon. There are also special Python mentoring programs, such as PyLadies. Python 3.10 deprecated WSTR, and added pattern matching to the language. API documentation generators. Tools that can generate documentation for Python API include PyDoc, Sphinx, PyDoc, and its forks, Doxygen and graph-havis, among others. Naming. Python's name is derived from the British comedy group Monty Python, whom Python creator Guido van Rossum enjoyed while developing the language. Monty Python references appear frequently in Python code and culture. For example, the metasyntactic variables often used in Python literature are spam and eggs instead of the traditional foo and bar. The official Python documentation also contains various references to Monty Python routines. The prefix py is used to show that something is related to Python. Examples of the use of this prefix in names of Python applications or libraries include Pygamy, a binding of SDL to Python, PyQt and PyGTK, which bind Qt and GTK to Python respectively, and PyPy, a Python implementation originally written in Python. Popularity. Since 2003, Python has consistently ranked in the top 10 most popular programming languages in the SHIOB Programming Community Index where, as of October 2021, it is the most popular language. It was selected Programming Language of the Year in 2007, 2010, 2018, and 2020. An empirical study found that scripting languages, such as Python, are more productive than conventional languages, such as C and Java, for programming problems involving string manipulation and search in a dictionary, and determined that memory consumption was often better than Java and not much worse than C or C++. Large organizations that use Python include Wikipedia, Google, Yahoo, CERN, NASA, Facebook, Amazon, Instagram, Spotify, and some smaller entities like ILM and EDA. The social news networking site Reddit was written mostly in Python. Uses. Python can serve as a scripting language for web applications, e.g., via mod_USGI for the Apache web server. With Web Server Gateway Interface, a standard API has evolved to facilitate these applications. Web frameworks like Django, Pylons, Pyramid, TurboGears, WEB2py, Tornado, Flask, Bottle, and Zope support developers in the design and maintenance of complex applications. PyJS and IronPython can be used to develop the client side of Ajax-based applications. SQL Alchemy can be used as a data mapper to a relational database. Twisted is a framework to program communications between computers, and is used by Dropbox. Libraries such as NumPy, SciPy, and Matplotlib allow the effective use of Python in scientific computing, with specialized libraries such as BioPython and Astropy providing domain-specific functionality. Sage Math is a computer algebra system with a notebook interface programmable in Python. Its library covers many aspects of mathematics, including algebra, combinatorics, numerical mathematics, number theory, and calculus. OpenCV has Python bindings with a rich set of features for computer vision and image processing. Python is commonly used in artificial intelligence projects and machine learning projects with the help of libraries like TensorFlow, Keras, PyTorch, and Scikit-learn. As a scripting language with a modular architecture, simple syntax, and rich text processing tools, Python is often used for natural language processing. Python can also be used to create games, with libraries such as Pygamy, which can make 2D games. Python has been successfully embedded in many software products as a scripting language, including in finite element method software such as Abacus, 3D parametric modelers like FreeCAD, 3D animation packages such as 3ds Max, Blender, Cinema 4D, Lightwave, Houdini, Maya, Modo, Motion Builder, Softimage, the visual effects compositor Nuke, 2D imaging programs like GIMP, Inkscape, Scribus, and Paint Shop Pro, and musical notation programs like ScoreWriter and Capella. GNU Debugger uses Python as a pretty printer to show complex structures such as C++ containers. ESRI promotes Python as the best choice for writing scripts in ArcGIS. It has also been used in several video games, and has been adopted as first of the 3 available programming languages in Google App Engine, the other 2 being Java and Go. Many operating systems include Python as a standard component. It ships with most Linux distributions, Amiga OS 4, FreeBSD, NetBSD, and OpenBSD, and can be used from the command line. Many Linux distributions use installers written in Python. Ubuntu uses the Ubiquity installer, while Red Hat Linux and Fedora Linux use the Anaconda installer. Gentoo Linux uses Python in its package management system, Portage. Python is used extensively in the information security industry, including in exploit development. Most of the Sugar software for the One Laptop Per Child EXO, now developed at Sugar Labs, is written in Python. The Raspberry Pi single-board computer project has adopted Python as its main user programming language. LibreOffice includes Python and intends to replace Java with Python. Its Python scripting provider is a core feature since version 4.0 from February 7, 2013. Languages influenced by Python. Python's design and philosophy have influenced many other programming languages. U uses indentation, a similar syntax, and a similar object model. Cobra uses indentation and a similar syntax, and its acknowledgements document lists Python first among languages that influenced it. CoffeeScript, a programming language that cross-compiles to JavaScript, has Python-inspired syntax. ECMAScript/JavaScript borrowed iterators and generators from Python. GDScript, a scripting language very similar to Python, built into the Godot game engine. Go is designed for the speed of working in a dynamic language like Python and shares the same syntax for slicing arrays. Groovy was motivated by the desire to bring the Python design philosophy to Java. Julia was designed to be as usable for general programming as Python. Nim uses indentation and similar syntax. Ruby's creator, Yukihiro Matsumoto, has said, "I wanted a scripting language that was more powerful than Perl, and more object-oriented than Python. That's why I decided to design my own language." Swift, a programming language developed by Apple, has some Python-inspired syntax. Python's development practices have also been emulated by other languages. For example, the practice of requiring a document describing the rationale for, and issues surrounding, a change to the language is also used in TCL, Erlang, and Swift. See also Python syntax and semantics. Pib. List of programming languages. History of programming languages. Comparison of programming languages.